Alex forgot to mention, Alex was my graduate PhD advisor as well, along with Alan Black. Today I'm mostly going to talk some of my dialogue work. Of course, I have also been working on other fields as well. I also work more and more on natural language generation. Recently, we have been also looking into multimodalities and plus machine learning in terms of increased data efficiency. Okay, let's get going. So a little bit of introduction if you're not in dialogues. There are usually two types of dialogue systems people would talk about. One is task-oriented systems, and the other is social chatbots or social conversational systems. Task-oriented systems usually have a goal. So basically the user and systems will together complete a task. They usually have an aligned goal. So the user knows what the system can do, and the system knows what the user is going to do exactly the thing that it is capable of. So they can book flights together, book restaurants, get bus information. So if you're in dialogue, you know what are the data sets I'm pointing you at. While social chatbots, the main goal for social conversational systems are talk about anything with anyone at any time. So it's really open-ended in a lot of ways. So here is an example of my student, Ms. Zhou, talking to our Amazon Alexa chatbot, Gangrok. So people may know we have like this Amazon Alexa price challenge for a couple of years now. It's about Amazon opening up their platform to the academic world. So all the schools can build chatbots and deploy on Amazon Alexa devices. So all the users from Alexa, so whoever has an Alexa device or Alexa or smart app can interact with these chatbots. So we can gather information we can gather data from these like real users in Amazon. So we have more than 1,000 conversations every day, and it has been going on for a couple of months right now. So it's really exciting. So one of the examples.
Our dog is named Bonsai, so he came with that name. We think it fits him pretty well.
That is a great name for a dog.
Yeah, he's kind of short, like a bonsai tree, so it works.
Tell me, how long have you had Bonsai?
We've had him for a little over a year now, yeah.
Oh, you must be great friends.
Yeah, we are.
So here's the conversation is really about, they find a mutually interested topic about pets. The chatbot is able to acknowledge information that the name of the dog and try to reuse that information. It's also able to express certain type of emotions, saying "aw," using some speech content.
Our dog is named Bob.
So we won the Alexa challenge in 2018. So currently we have a new challenge going, which is going to be announced winners soon in next month. So it was really exciting to see even the industry is really focusing a lot, saying that these conversational systems will have a huge impact to the world. I'm really excited that my students, when 2018, I joined UC Davis 2017. So 2018 is where all my students are first year graduate students. They were able to really that really excites me that after a year of working on the problem, they were able to win the prize, which is basically building the best chatbot in the world. So they were excited about the $500,000 that they split among themselves as a cash bonus. But for me, it's really exciting to beat Alex in the competition.
Hey.
So we really have received a lot of interesting feedback from real users because we have been reaching millions of users in this process, which is very exciting. We have seen like people saying like, oh, Alexa is my family. I like to talk to it every day before I go to sleep. And there are people saying like, Alexa is my best friend now. So really see these smart home devices these chatbots are being sort of like a member of the household. Children like to talk to it, elderlies like to talk to it, people who are bored like to talk to it. There are people with different motivations who wanted to talk to the chatbots. So really do see that it is impacting our everyday life. So one of the really interesting part of the conversational system is there's never a real clear cut of task-oriented system or social chatbots. It's really about a lot of times there are some areas that is in the middle. When we talk about this, particularly today, we're going to talk about one class of conversational systems, persuasive conversational systems. So it has certain parts that are particularly has the goal to achieve, but there are certain parts that you need social interactions to build trust and warmth in order to achieve your goal. So it is, I would consider it much more difficult than just simply building a chatbot. So what can a chatbot really do if they have the ability to persuade? So there are two types of abilities that we're thinking about. First is we can directly change people's beliefs, attitudes, or behaviors. The other is these systems can serve as training systems to teach people how to persuade other people. As we know, persuasive power or persuasive skills are very sought out in the working place. But first, we're talking about three small applications we have been doing. First is exercise persuasion. We have a collaboration with UCSF, which this is especially on how to persuade people who may have health problems to keep exercising every day. Second, social distancing. For example, in the pandemic, these kind of health habit, can we actually, through Amazon Alexa Prize, persuade people not keep social distancing. And the other is suicide counseling. I've been partnering with Suicide Helpline to build simulations for them to train new counselors. So basically, the chatbot is going to act as the suicide visitors, so that we have different scenarios for the junior counselors to train. So we know persuasion or negotiations are really difficult even for humans. So it started with a lot of literatures in social psychology. People just want to understand the world and how people interact with each other. And later it got really popular in marketing and in the business world, because we were talking about advertisement. We want to persuade people to buy stuff, we want to negotiate contracts. But these all, we have a lot of books and courses specifically on persuasion or negotiation. Then so many human knowledge, how can we input that into a robot and make this machine understand how to persuade people, which is super difficult. Today, we're gonna talk about some of the basics that we have been doing over the 2 years, but there are much more to talk about. First, where do we get the data to imitate human? How do we understand deep semantics so that we build safe systems? Finally, what are the conversational strategies, persuasive strategies that system can adopt? Data challenge is always there. As we all know, conversational systems are different than other natural language processing tasks that it has multiple turns. So if you say something slightly different from the ground truth that you have before, you go into a totally different path. So you have this kind of exponential growth of different way of completing the task or not completing the task. So how are you gonna collect data to cover the entire tree? And then the most important part is you're talking about, you're interacting with people. Well, people are so different from each other's. One person may like pets, the other person might like football. How are we gonna make sure everyone has a happy ending went into the goal? So the second part of the challenge is really about semantic understanding. We know right now all these pre-training models are pretty good in handling lexicals, being able to get fluent and generated utterances or understand service forms. But when it comes to deep semantics, it's really still hard. We still see Microsoft Tay was a chatbot from Microsoft who was deployed in Twitter, and within a day it became racist because it was learning from the user. Of course, we know these systems all had a profanity filter, but a lot of times people get really creative when they wanted to say dirty things. So we encounter that a lot in the Amazon Alexa challenge as well. So how can we make sure that we understand exactly what the user's saying so that we can build safe systems? At the same time, we also wanted to make sure what the chatbot was saying or whatever the dialogue system was saying to make sure it was safe. Then finally, strategies are very important. We're thinking about not only the semantics. Marry me is important, but how are you presenting the information to your loved one is even more important. Of course, balloons and flowers are much more persuasive than cardbox and pizza. So how are we going to select the right conversational strategy, the persuasive strategies to achieve your goal? It's very difficult, but we're going to talk about that later. So today we're going to basically focus on the 3 points that we laid out. How do we collect realistic data that we can model off to our best? Semantics, how can we build safe systems with limited data? Because we know conversational data is always hard to collect. Is there a way that we can use some human input in the process as a scaffold to encourage the system to learn better and be more safe? Strategies, when we talk about how people react to the system, is important. What the strategies we're making the system to do with respect to different users are also important. How do we optimize the traces of different strategies we impose on the users are important. First, we're going to focus on one small topic, which is persuasion for good for support charities. So there are many applications under the umbrella of persuasive conversational systems. But today we're just going to focus on one thing, building a chatbot that can persuade people to donate to charities. Previously, we know data collection in dialogue system is always a major challenge. Real production dialogues are the best thing to model off, but it's always not available to the general public due to user privacy. So we have been interacting with many companies, and whenever we talk about data, they will really shy away from it because it's really about a lot of public influences they are inserting on the public. They have the responsibility to protect their user privacy. So what can we do? So people come up with this role play. So you go on crowdsource platforms like Mechanical Turk. You hire 2 Turkers. One play the robot, the other play the user, and then they have multiple scenarios. For example, the restaurant booking, the multi-walls or Cambridge restaurant are examples of these conversations. So you tell the person, say, hey, you're gonna book a restaurant with 2 people, Italian, on the north side of town. So then they started to have a conversation, but still, it works okay for collaborative tasks that you have a joint goal. But when it comes to persuasion or negotiation tasks, when you have to have a real incentive to start the negotiation or a persuasion process, it gets a bit tricky. So there is a Facebook Deal No Deal. Stanford has a Craigslist bargain. Both of them have problems in terms of how do we really engage the user to act in the role that is really realistic. Incentives are very important, but how do we set the incentive is really difficult. So we come up with using monetary as incentive, as everybody would, but we try to play a trick for the 2 people in the conversation. So the 2 people, one is going to be the persuader. They will receive bonus when the other person, the persuadee, will donate. While the persuadee, they're not going to be told what they're going to do and when they come into the conversation. We're only going to tell them you're going to talk about you, and the other person is going to talk about a certain charity. Well, everything else, all the information is going to be coming from the persuader. So the persuader is going to tell the persuadee that if he donates to the charity, it will be a lot of good things happen, blah, blah, blah. And in the same time, they were going to persuade the other person to donate their own task bonus. So here, the interesting part is really about all the persuader and persuadee, they come into the task. Their turkers, what they want to do is to finish the task and get as much money, as much bonus as they could. While the persuaders, if they do a good job, they get the other person to donate, they get extra money. So good incentive for them. While as for the persuadee, they want the bonus. So that was the initial attitude they have when they come in, so it was intrinsic. While after the persuader had a conversation with them, they need to change that attitude towards that, I want to share some of my bonus to the charity to help this particular charity called Save the Children. So this sort of like dynamic fits well with their own incentive in coming to do the task. So for the two people, when they first come into the task, they're going to do a pre-task survey. Before the task, they're going to do a survey so we can collect their information about big five personality. Are you an extroversion, introversion? Are you neurotic or or more neurotic, neuroticisms, openness, and so on. Moral foundations. Are you supportive of authority? Are you more towards liberty? Decision style. Are you emotional decision maker or rational decision maker? So these are the information we're going to collect. So later we can adapt to these individual personalities in using different conversational strategies. After they finish the survey, they will come in to have a conversation together. As we talked about, the persuader will try to persuading the other person to donate, while the persuadee, the person is going to defend their own earnings according to their own task. And then finally, they will come together. They're going to enter how much they're going to donate directly on the website, and then that money would directly send it to Save the Children. So the turkers are actually donating real money, so it ties into with their real benefits. And every user can only do the task once, so they don't know how this actually flowed before they actually go into the task. So we collect around 1,000 conversations. We're able to erase around $500. So we're paying $2 each for their task, and we give them an extra $2 for bonus. So people can choose to donate the entire $2 bonus, or they can choose to donate partial of that or not donating at all. So here's an example conversations that we collected. We see they are really trying hard. So this is the persuader. He's going to say, you're probably on a computer right now, so you probably have quite a bit of money yourself. Don't you think you could spare maybe 25 cents for some needy children around the world? And this is a persuadee. No, thank you. Do you have children yourself? What if your children were in a position these kids are in? Wouldn't you want someone to help them? Where are those children's parents? If only they had a parental support, but in war-torn countries like Syria, their parents are being killed in wars or are fighting for their country. They have no help, and that's why they need your support. Please find it in your heart to just give a little bit tonight. That's all I'm asking. So you can see the conversation is pretty realistic. They're using a lot of words to try to persuade the other, but definitely we see this kind of imbalance that the persuadee usually say fewer words than persuader. Do we have any questions about data collection? So we do see one QA. Yes, so some algorithms to be used to persuade people to donate to a political campaign. Yes, so there is always a problem that we are talking about in terms of ethical use of technology. We'll definitely be, we will talking about that later in our talk, because when you think about your persuading donation, we collaborate with Save the Children. What if somebody took our technology and started to spam people and collect money for their own purpose? We're going to talk about that later in our talk, but this is definitely a very important thing. But we have to say persuasion in itself Technology in itself is interesting to look at, but how we use it and how we can regulate it is another interesting problem. Any other questions on the data collection before we move on to the algorithm? Okay, cool. So our entire goal of the later part of the talk is trying to make, to replace the persuader.
Yeah, Joe, just a moment. Kevin has a question.
Yes.
Oh, hi, can you hear me? This is Kevin Du.
Hi, Kevin.
Hey, I just have a brief question about the dialogue structure. Usually how long does it take to persuade someone to do this task, and how much sort of topic-specific reasoning do people do? Or is it like a very quick one-off, you either donate or don't donate?
Yes, that's a good question. So we make our conversation is like you can talk as long as you want, as long as your partners are there. So we do have a minimum length of the conversation, which is 10 turns. We definitely do see people haggle a lot in these kind of conversation. For every conversation, it's a little bit different. Our data is also public. You can also try to look at it yourself. But usually you see there are different types of people. The one type of people, they are sort of more inclined to donate at very first beginning. But what they are going to do is going to elicit more information about the organizations and how the people are going to use the money to sort of like convince them that it's the real charity that they want to donate. While the other type of people, they don't want to donate at first, and they keep defending themselves, and in the end they even didn't donate. So it varies a lot, but we definitely do see that for the persuader, he's trying to, from the very beginning, trying to use different kind of strategies to persuade the other people. But sure, they're Turkers. They're not like a professional, like a charity fundraisers. So we definitely see there are differences between different Turkers too.
Okay, thanks.
And Joe, Hongyan asks, what percentage of the samples you get are negative, meaning failing to persuade? Hongyan, you're also welcome to ask your question orally, but let Joe answer right now.
Yeah, we're going to talk about that later too. So it's around more than, so we're talking about percentage. I think that we have exact numbers. It's around a little bit more than half of the people donated to the charity. Okay, so I also have to mention that we collected the data within the US. So we constrained the Turker to be United States citizen, located in the United States and native English speakers. So that definitely has an impact in terms of the donation rate across different countries. It may differ. So now we're ready to start building dialogue systems. First, we want to understand what people are talking about so that we can actually do some analysis and utilize that for building systems. So we build a hierarchical intent annotation scheme. So when an utterance come in, it could be talking about strictly on task, or it could be a little bit on social. So when we talk about social, we're going to use our Meta's data annotation scheme, which is created for Amazon Alexa chatbot. These are dialogue acts are strictly on some syntactical informations and social interactions, such as open question, yes, no questions, statements, double-edged questions, and stuff like that. Greeting, thank you. Well, for the task, specifically for this one, we're talking about whether the people agree to donate, disagree to donate, request task information. So these are sort of like intents we care about in this particular task to move forward. While social parts are a bit more syntactic in a way that because there are a lot of semantic information that can cover. So the same conversation with the annotation. For example, we say you're probably on a computer right now, so you probably have quite a bit of money. So this particular is a task information utterance, and the goal was to request a donation. So here, particular proposal. When the other persuadees say no, thank you, it's a task information, disagree to donate. The user say, do you have, the persuader say, do you have children yourself? It's a social utterance. It is yes or no question. What if your children were in position these kids are in? Yes or no question. Where are those children's parents? Open question and social. Now, once that we have these tags, we can, so we had another study also looking at the percentage of these, how these dialogue acts associate with different type of personalities, but we're going to talk about that later. So now we're ready to build a chatbot that is going to replace the persuader. What we're going to trying to do here in particular is we're going to use some semantic scaffolds, which are the annotations that we annotated to help the machine to require less data to learn. As we know, we only have 1,000 conversations. It is totally not enough to do end-to-end. So a little bit of introduction if you're not an expert in dialogue systems. So conversational systems are usually classical modular dialogue frameworks are most popular. So usually you have 4 modules. One, an utterance comes in. It first goes through the natural language understanding module. Then the output of natural language understanding module goes in as the input of dialogue state tracker. And the dialogue state tracker's output is going to go to dialogue policy learning as an input. And dialogue policy learning's output is going to go to natural language generation module as an input. Finally, you can generate, decode the system utterance. So if I try to make it easier to understand. So the user, the persuadee says, tell me more about the organization. So we're going to translate that natural language sentence into a tag, which is task inquiry. This is an NLU process. Once an NLU process is done, according to the dialogue history and so on, you extract most important information through the conversation you want to remember. For example, in dialogue systems at book restaurants, you want to remember the name of the restaurant, the time of the booking, and so on. But here, for simplicity, for example, here we just care about donation, but we do in reality we had other tags. Once that we have the state tracking, then we're going to use that information to plan what the robot is going to do. Here we're going to look at the dialogue history. Sometimes we also look at the most recent dialogue act of the user. Here it's task inquiry. We don't have any donation. We decide the robot should provide information about factual information about the organization to respond to the task inquiry. And then now we know that the action of the chatbot is provide facts. Then we're ready to go into natural language generation to generate some natural language that carries that particular intent. Save the children, help the millions of Syrian children who are facing the threat of violence. So this is what we usually call a classical modular dialogue framework, which is still very popular among the industry. So there are some drawbacks. First, difficult to update because we have 4 modules and the input and output were cascaded over. So if you change one module, you have to change everything else. You require a lot of heavy expert involvement in tuning all of these 4 modules together. You have heavy annotations that you need to do. As for every conversation, if you don't have tags for intent from the user or the system, you can't use them for training. So that's why everybody was saying, let's just skip all these kind of annotation. Can we just do end-to-end? We have this kind of GPT-2. We have these kind of variants of different things, Dialog, GPT-2, Blender. Can we just use that? Yes, of course. You can use the user utterance which are going in and the system is going out. There's no intermediate step, whatever. But the problem is still there in a way that it's really difficult to perform error analysis. This is true for all natural language big models. While dialogues, it's even worse in a way that there are some processes that are going on in the middle that people really want to understand. So right now, if the user says something and the system didn't answer the give the right response, we don't know what to do. We're going to panically tuning the big neural network model. While the previous modular-based model, you can look at, oh, it's an understanding that is making the error. Let's collect more data on an NLU module so that we can fix that error. But now in the end-to-end framework, you can't do that. For a simple information request task, like a restaurant information, we have seen a lot of papers have been doing that. It was successful, but it needs thousands of data to train such simple information request tests that has like 3 intents. So they're really using the dialogues in a very inefficient way. And we know dialogue systems are always in a low resource setting. It's really costly to collect realistic dialogues, and it's really costly to annotate them. So what can we do? We have this, we proposed this module in our lab called Modular Supervision. We really wanted to bring the best of the both frameworks together. So it is still an end-to-end trainable module, but it takes supervision from all 4 components. So you can really think about it as a multi-task training process. You have end-to-end encoder decoder for all 4 modules, but you're optimizing them together. So all of them share a same encoder, and the input of it, like for example, the previous dialogue state, the previous response of the system, the current response of the user. They all go into the same encoder, and then they will start from the first decoding the natural language understanding, which is the tag of the user intent. During the training, you can feed in the task inquiry, which is the dialogue act of the user utterance. And then you can feed it in the next one is dialogue state tracking. It's basically the output of the next state, the input of the next state. And if you have certain interactions that you want to do with the database, you can do that through our framework. But here particularly, we're talking about charity donation. We don't really specifically have database. But when it comes to like restaurant booking, we wanted to interact with the database through the DSD modules as well to go so that you can output the database information back to the policy planning module. And after that, we know the states. We're going to decode another one, which is the system's action. And finally, we're going to decode the natural language of the system. So everything was connected through hidden states. So it's no longer connected through a symbolic input and output. Now it's connected through a hidden state. So if you have an error that propagates through the network, you can back propagate through in the training process. Now we don't really have this kind of misalignment. So when you really look at it, it's a simple condition generation, right? So you have the sequence to sequence model for the dialogue natural language understanding module. You have the input and you decode a hidden state MT. And then the next time when you're trying to decode the dialogue state tracking results, you condition it on the hidden state MT and you generate this kind of hidden state ST, and it's all concatenated together. And the nice part about it, it can also output the symbolic output of each module. So instead of only outputting the MT hidden state, you can also output the next, the intent of the user utterance. So that's gonna help you for error analysis. Another thing about the module is very flexible. It can accept different types of data with different types of labeling. As we know, not a lot of times that we have to annotate all the conversation. What if we have some conversations are annotated? Some of them are not annotated. Particularly for MOS, you can basically combine the two type of data seamlessly. Because what you have is, for example, you don't have annotations for anything. You just basically do not update the gradients for the first 3 modules. You just update the gradient for the last one, because you always have the user utterance and system utterance at the same time. So this is also very flexible in terms of incrementally update your model if you collected more data, if you collected more annotation. So now we're ready to build a system. So before we're doing anything, right now we have to pre-train the model. So what we're going to pre-train our model with is going to use some Alexa-related social conversational data that we already annotated for MEDA's annotation scheme, which is basically the social dialogue acts. So we have social dialogue acts for these conversations, but we don't have the task dialogue acts for particular persuasion because they are not really persuasion dialogue systems. But it's good enough for us to get started for understanding. So we have the shared encoder. So for these conversations, people say hello, and then you say, hello, how are you doing? And the understanding module says this is greeting in terms of dialogue act. And the history is nothing. We don't record history for this type of conversations. The system intended we should greet back, and then the system particularly say, I'm good. Now, after pre-training dialogue system with social data, that we're gonna fine tune it with our task data. So as we know, we have, so we annotated 300 data conversations that are successful in persuading people to donate. Well, another 700 data points we didn't annotate because we have limited human power for this. So what we're gonna do is we usually gonna do fine tune our model on these kind of 700 data that we haven't sort of updated, annotated, but then fine tune it with the annotated data in the end. So what we do is this particular conversation is the previous system learn says, Save the Children is providing help to children. And you said, tell me more about the organization. So that was the input and also the history of the belief state that goes into the shared encoder. And then first we decode natural language understanding. During the training, we're gonna feed the input of the user intent, which is request for the task information. And the history is donation equals to 0. System intent is to provide facts about the organization, and particularly say, sure, Save the Children is a blah, blah organization. So the advantage of this particular modular supervised model is that it's easy to update because it's a trained end-to-end. You don't have to require a lot of effort to individually update them. It will require less expert involvement. As we know, you just have one model that you need to tune your parameters for. It's easy to perform error analysis because in the testing, you can output individual discrete input for what the user intent is, what is the state at the moment, so that you can see, oh, if the user intent wasn't good enough, let's collect more complex user input related conversations and to patch up that problem. And then it can handle complex tasks. But still, when we talk about how many data you have, how many annotation you need, it's always a balance. If you have a lot of data, if you're a big company, you already have a lot of customer service conversation from real human, they probably don't need to annotate a lot to give them guidance on what the model should be. Well, if you're a startup, you only have like 10 conversations, we suggest you to annotate all of them for sure, just to see if it increases your dialogue system performance. But this is always a trade-off. It's also a design choice. So if you think your system wasn't doing good enough, you can use your money to collect more data, or you can use your money to annotate more conversation. But this is always a trade-off. Now we're ready to test our system. So what we're going to do is simply as we're going to keep our original data collection mechanical Turk setting. The only thing that we change is we're going to replace with Persuader into a chatbot that we built. So as we talked about before, the human Turkers, they have, so here is the probability of how many people donated. So 54.2% of people donated. And then for our baseline, what we did is just an end-to-end GPT-based model can elicit 32.5% of people donate. And use our modular supervision, 300 dialogues with labels, we get 37.6 improvement. But it's not good enough. It's way below what the human was doing. So what can we do? We look at some of the conversations. We do find that so for example, this particular conversation, the user was saying, can I get a refund on my donation? And the system said, yes, of course, everyone can get a refund. Of course, that was not true. The reason the system was generating this is because we have never seen Turker saying, can I get a refund on my donation in the training data? And the system was trying to basically provide information, and it was copying what the users say and saying, of course, everyone can get a refund. So, but this is going to be a real problem because it wasn't saying something true. Well, when we talk about persuasion, if you're using the sort of like lies to get to your goal, it's no longer persuasion, it's deception, right? And also very importantly, if you're gonna hire this chatbot to run your customer service agent, or you're going to bankrupt that company very soon and get a bad reputation. So what can we do? So this really comes into the real challenge of how can we deploy generative models in real scenarios. Everybody's looking at that problem. What can we do? So particularly we were saying like we need a safety net in deployment. Basically you can think about you have this exponential tree that people are going through different paths to get to the goal. What you want to do is you want to cut off the branch that is going to give you problems, ethical questions, and dialogue acts that you cannot use. So particularly, we're going to use this kind of response rankers. So RMS, any dialogue generation model, if it's a generator, you can decode multiple candidates using different sampling. You can use nucleus sampling, for example. Then you would have, because our MOS model has this kind of dialogue intent and slots information corresponding with the output of the final sentence. So we'll see you can decode multiple sentences that have a diverse intent and semantic slots. For example, here the viewer is saying, "How much would you donate yourself?" So basically, the persuader say, "Hey, persuader, are you going to donate? If you're not going to donate, probably I want to donate." So some intent of that. And then this particular intended request donation amount and nothing without semantic slot. So according to our decoder, we can decode multiple stuff. For example, we say, well, I will donate $1. So I will provide donation amount, and the semantic slot is donation amount equals to 1. And then people say things like thinking, I don't have money, refuse to donate, the donation amount is equal to 0. So you have these kind of various different candidates. What you can do is you can ask a human who has persuasive conversational trainings for us. You can ask them to select according to the intent, given the history of the intents you have seen so far, which one would you select? So the expert is really operating on the intent level, which is in a much smaller space than the natural language space, right? So you can ask them to provide some demonstrations, and you don't really need a lot of demonstration that you can control your intent. So now the robot can imitate how to choose the intent according to you, and then if you choose the intent, that the natural sentence comes along with it. Of course, this is going to help us in terms of planning as well, because previously we're asking Turkers to do that. Turkers are average people; they're not experts, so their persuasion sort of strategies, looking at the history, may not be the optimal dialogue policy. So these experts are also giving us sort of really good data. So with that, with the dialogues of the expert demonstration, with the ranker, we're actually going to be able to improve 10% of the probability of persuading other people to donate. Of course, we have certain problems still in terms of it's a conditional generation. Sometimes the decoded utterance and the system intent are not perfectly aligned. There will be errors and disalignment, but it's relatively small in case that, because we also put in some regularizations later. But still, I was saying that this is not bulletproof. We're still having problems every now and then, but it's much better in terms of we don't look at don't use human demonstrations. Okay, we still have like a 7% away from the average human Turkers. So what are we going to do? So we're going to look at the strategies. So here are some previous examples that we see in the dialogues that we collected in the user study of the human interacting with our chatbot. The chatbot say, have you heard of the charity called Save the Children? No, I haven't. What is it about? It's an international organization that promotes children's rights, provide relief, and support children in developing countries. Does that sound like something you don't get behind? And say, this particular is doing a request donation. They're using a credibility appeal particularly. So credibility appeal, as we know, sort of is talking about this charity is having a lot of credible information, you should get behind it, and so on. And the users say, no, thank you, I'm already making a difference in many children's lives. So probably a parent. So it having a negative intent towards it. And then again, the system chose another proposed donation strategy. Save the Children was founded in 1919. Obviously, it's another credibility appeal, but lack of diversity, because we already talked about all these credible information, but the other user wasn't very interested. What if we change it into, that's great, it sounds like it's an issue you really care about, then why not put some of that effort into a charity that's doing really good work like Save the Children, which is a logical appeal, basically following the logic of what the user said before and lead them into the goal, which is persuasion. Okay, do we have any questions in the middle before we move on to the final parts of the strategy?
Audience, any questions?
How much time left?
We have another 10 minutes.
Okay, so there's one hand. Okay, Hong Yuan is right. Did I?
Joe, hold on. There is a question from Hong Yuan. So
Yeah.
Hong Yuan, go ahead.
Oh, hi. Can anybody hear me?
Yes.
Okay, thank you. Thanks for walking us.
We can hear you.
Hey, Joe. Thanks for talking us through the architecture. So basically, I'm very confused about like how the data is used to train the model. Is it imitation learning or is it reinforcement learning?
Oh, it's imitation learning.
It is imitation learning. Now, how do you even use the negative sample in the imitation learning? Because if you use the negative samples, in the end, you learn like how to not persuade, right? Or how to fit it.
No, we're not using the negative sample.
Okay.
Samples there are just for the expert to choose.
Okay, so are you saying like, but when you, yeah, this is actually also related to my question about the data collecting. So you collect the data and you said there are a good portion of the data which are actually negative because they, in the end, the persuader failed the task. So
yeah.
So is your answer? So your answer is you don't use such data to train this model, right?
No. So we used all the data that we have, but you're definitely right. Certain data points we have, basically successful dialogues, we weight them heavily over the unsuccessful dialogues during the training process. So there is a catch there. The reason that we also would use the unsuccessful data is it also helps us in, for example, understanding and stuff like that.
Okay, so have you done such, please interrupt me if I'm taking too long time. So my last question is, my last question for this section is, have you considered or do some ablation study like if I only use the negative sample to learn the language model related part, but I don't use that data for training signal? Would you think that can actually help the training, or do you have such experiments?
We did strip away some of the negative data, but it felt like in the sort of like coherency of the conversation, it reduces. And because if you reduce the coherence of the conversation, basically your persuasion output is also going to be not that good. So it's highly correlated between the two. Yeah, but it's a good question. We're actually going to get to that a little bit later.
Okay, thank you.
So here we definitely see that if we wanted to use something like a diversity of with respect to the user's reaction, we change our persuasive strategies. We may improve our persuasive power. So particularly, we're going to look at some different types of strategies we annotated. Credibility appeal. Emotional appeal is about raising the emotion of the other person. Logical appeal is basically having a logic to lead us to the final goal. Self-modeling is saying, oh, I would donate as well. So basically use yourself as an example. Personal story is talking about your own personal story about donation. Donation info is providing details. How are you going to donate? What the process is. Foot in the door is basic. Even 5 cents would help a lot. Basically, talking about if you just start with very limited amount and then that would be good enough, and then we gradually ask for more. So every conversation, you can label them with all these kind of different strategies and how the reaction of the user towards these strategies. So now you can, the obvious thing you can think about is you're not only going to take the dialogue act of the system in the planning and generating the surface form, but you're also going to take the strategy into consideration. So you basically have an extra modality, sort of like a module inserted in between this. So it's a dialogue policy learning is saying like we need to propose a donation at this moment, what strategy are we going to use, and then finally what natural language sentence are we going to talk. So obviously you want to change the dialogue history to not only incorporate the donation information, but also incorporate strategies that we used before. But we still are talking about the history is purely semantic. You add into the strategy information into the history. Still, we had a lot of problems in terms of these symbolic trajectories does not really take advantage of the information shared among all successful conversations, because we're now training with all conversations, right? Some of them are not really successful. If we're just learning from all conversations, we diluted the useful information between the successful conversations in terms of strategy choices. So what we're going to do is we're going to learn sort of like common strategy structure within these successful conversations. So you can learn these sort of the trajectory using different machine learning tools. Like you can think about it as like n-grams, right? You want to find the commonality between these successful conversations. Particularly, we used a finite state transducer, basically trying to greedily sort of find sort of some local structure shared among the successful conversation. So in reality, we have much more nodes than this, but this is sort of an example that we see. So once we have this kind of shared structure, then for each conversation, we can actually walk through the structure in terms of different states. And then the next thing is simply as we're going to combine the states with whatever we have, this kind of giant model as well. So what we're going to do in terms of these converting in these discrete state into distributions for each possible actions, we have probability attached to it, and we just use this probability of transition probability as their sort of each dimension's value, so that you can see that different states were represented by this kind of transition probability each of them has for different strategies. And then you want to add this kind of vectors with our big shared modular model. Particularly, we're going to add that into the encoder. So first, we're going to change the encoder into hierarchical encoder. So the system says something, you just say something, system says something else. So we're going to encode each individual utterance into a sort of a more compact state. And then we're going to use a dialogue encoder, an LSTM, that considers the timestamp to combine these utterances. So we have a more fine-grained encoding process. And then we're going to put the strategy, condense the strategy information in the middle layer to concatenate them together, and finally come up with a more condensed information that is not only on semantic information of the user system utterance, but also on strategies that are related to the history. So finally, we're going to feed that into hidden states into the different modules that we created, and we can train our module again. So with this extra information on the strategy history tracking, we can improve our performance for another 3%. So we really do see from the vanilla end-to-end training, you inject semantics, you improve 5%, you improve safety, this kind of cutting of the sort of branches, and also getting more expert examples, you get 47. If you have some strategy information taken into consideration, you get 51.1%. And later, we have another Kai paper that if you adapt the user's personality, so we had some data before. So basically, if the person is more sort of like persuasive, if they support authority, then don't use personal strategies. Don't talk about kids. If they are more sort of personal. They support liberties and stuff. When they talk about these kind of personal stuff like kids and wars, they actually donate more. So you can actually do better than average human checkers. So some of the things that we take away from the work is that you can use these algorithms to do all different types of tasks, not only for persuasive tasks. For example, the modular supervision task. You can use it for task-oriented system or use the social. Basically, just get rid of the state tracker. You can use this kind of Moss ranker model that provides more security that in the system so that you can deploy in a real-world application, such as Zhou. The company is using it for Lenovo laptop information customer service. Tencent is using our model to do like sports-related information chit-chat. Strategy tracking, for example, is really important. It can be used for various tasks such as physical exercise improvements and so on. We have some public data sets we release. For example, the Persuasion for Good is a data set that is around 1,000 conversations. We also have another 600, more than 600 data points for human-machine conversations. So dialogue systems are really requiring a lot of natural language processing skills. You're talking about understanding, you're talking about managing, you're talking about generating information. But also you're thinking about your robot, you should imitate, so in a way that how humans interact with each other. They're not taking only the language in itself, the symbolic outputs, but they're also taking the audio, vision, touch, all these sensories information. So another part of my research is also on multimodal learning. Another one is on common sense. And when we talk about conversational assistants, a lot of times these systems do not have common sense in our conditions. So they will say things that are out of our expectations, which is weird. So what we wanted to do is how can we actually incorporate these informations in our system and make sure that our system has certain common sense of mutual grounds that we can start with the human interaction. Finally, we want to also consider human factors in our conversation. So this is sometimes a lot of time people ignore because people are so different from each other. And when we talk about conversational system, we're really making sure that we wanted to evaluate our systems on the final outcomes, which is how users feel about your system. So this is really important. So over the past years, past couple of years, we have been working on various directions on that. Finally, I would just use one more minute talking about conversational systems are not just like using other things to incorporate in itself, but it can also help other fields such as machine learning, HCI, robotics, and security. For example, we have our work just submitted to EMNLP. How can we use communication, natural language, and interactions to sort of expand the bandwidth between machine learning, so annotation process and machine learning training. So you can elicit information from the user in a way that adds explanation or reasoning to help machine learning algorithms to increase their data efficiency. Ethical considerations, as we talked about, and there's a huge topic that we do with HCI. For example, if we tell people, so this is an anecdote that we had in our study. We tell people exactly this is a chatbot, but still, in the end of the conversation, we give them a survey with them. Do you think your partner is a human or a chatbot? 36%, more than a third of people think that they're talking to a human, but in reality, they're talking to a chatbot. And also, we already disclose ourselves as a chatbot. So California state law requires people to disclose that if they're using a chatbot, if there is a commercial or political information involved. But still, even by doing that, following the law, still 36% of people don't believe it. So we're not really talking about this chatbot is so good that it can pass the Turing test of a human. But what we are talking about is the general public wasn't educated enough how our systems can be these days, because they were guessing that, oh, this bot is really good. I don't think bot can do that well. There must be a human behind it, you know. So really, we wanted to see how can we raise the public awareness that conversational systems, natural language processing have been improving a lot over the past decade. And it can do a lot of things that a lot of normal people wouldn't imagine these systems can do. So there are certain ways that we can educate them that how these systems do. So one thing that we come up with, we make our chatbot available to everyone. So people can interact with like Amazon-based Alexa to see how our chatbot is really reacting. And through the interaction, they will know what the chatbots can do and they cannot do. So next time they would not be fooled by these chatbots to actually put money into certain things that the chatbot is trying to scam them for. Of course, there's one more step that we can do as a community, which is providing tools for people to identify these chatbots or potentially even harmful humans to scam people for money. So this is DARPA project. You can really think about, we're building a chatbot to help you to screen attackers. So we want to prolong the conversation at the same time as well, so we can occupy these spammers or these attackers' time over time. So they don't get to really the vulnerable people to elicit money from them. So this is sort of another situation of the power play, but it's also in a way that you really think it's not collaborative in a way. Both of you has different utility functions. Finally, we also want to also have collaboration with the robot system to think about if the robot, the chatbots can move, can have different gestures or behaviors, what can it do? It will really bring up, open up the space a lot. For example, one of the application we came up with a real estate agent. So can our system sell real estate? You can really think that you don't have to have an appointment with your real estate agents anymore. You can just go into her house and the robot will show you everything and persuade you to buy a big house. Okay, thank you. Thanks everyone. I'm going a little bit over time.
No, this is good. First of all, thank you. A big hand from everybody. Right. This is great. You know, it's sort of reminding all of us who are speech scientists and engineers that there's a very human aspect to speech and language, and you're blending it nicely into these dialogue systems. So we have time for a few questions. We started a little late, so we can go a little bit over. There's a question from Surya Kasturi, Zhou, in the QA box about the FSAs and the transition probabilities. So if you could take that.
Yeah, these transition probabilities are calculated based on the annotated conversation. And then, so basically you initially, so I didn't go into details about how you construct your finite state transducer. So it's a greedy process of finite state transducer. So you can think about, initially you have just 0 state. So you calculate all possible transitions from how many actually utterances are positive towards certain persuasion, credibility appeal, how much of that is. And then you're reducing the entropy of this sort of states by expanding it to have multiple states. And then in the end, you'll get like a huge states with a huge number of states.
Thanks. Kevin says thank you in the Q&A box. Yes, Kevin.
Oh, thank you.
Any other questions from the audience? We have a few minutes. Jason, Zhou. Anyone? Surya says, there's a follow-up, Joe, if you could just take it.
Okay, let's see. Would the model know when to stop persuasion too? Oh, yeah. So we do have, so we have a couple of things that we did in our conversational system. So if the people say that I agree to, so if we detect agree to donate, we're pretty happy, but we're going to do, can you donate a bit more? So we always elicit more donation. But if people say they don't want to donate more 2 times, then we just stop there.
Nice. There's a question from Eric Sound in, so Eric, go ahead.
Yes. So because the system really doesn't have the cognitive ability to understand the content of what's being said and what the conversation is about, then is it correct to say that you're really exploiting the habits of people when they tend to do this task over and over again, and they tend to follow certain patterns in the way the conversation rolls, and you're trying to track that. But if someone deviates off of that to say, well, do you have children yourself? Oh, how many? Or, you know, there's so many directions you could go in that actually do require understanding what's going on. But they just don't, people don't happen to do that. But if they did get off on that direction, then the system would be totally dead in the water. Is that a correct interpretation?
Yeah, you can consider that as, but most of the time when you say I have children, these were already shown in the data sets in training. So that actually we can do pretty well. But if we do something totally off the topic, we can't do that well. But because we have some pre-training data of the social conversational system, so they can still sort of like say something related, and then trying to like bring back to the topic again, and then so you can acknowledge that, oh, that's interesting, and then you can say something directly to the task, like save the children is blah blah blah. So there's always sort of like a way that you can sort of come back, but for sure, if you keep like going off topic, we can't do that.
And Jason, go ahead.
Hey, thanks, Joe, for a really nice talk. So I like the Moss architecture a lot, and I have a low-level question about how you deal with the intermediate supervision. As I understand it, you've basically turned this into like a big seek-to-seek model, where now instead of just predicting the utterance, you predict the concatenation of some intermediate strings and then the final utterance. And how do you determine the lengths of those intermediate strings? Is this just like predict the purple string and then a boundary symbol and then the green string and then a boundary symbol? And if so, then what do you do in the case where some of the annotation is missing? Not for the whole system, but just for a particular turn in the dialog.
Yeah, so it actually is not really a concatenated decoding, because you really have like 4 different decoders. So, so the first decoder is basically you decode the intent of the user, and then you have the sort of hidden state that goes on. So that every time you just decode one string. So for this guy, it's one decoder that decodes like task inquiry. Another second decoder decodes donation equals to 0, and the third one it provide a facts, and then the fourth is like save the children, blah blah. So it's not really an entire string. But there is also work from other people that they were feeding the entire thing as a string as one encoder and put everything as one decoder. So there are people doing that before. But I think that Microsoft Research did that recently as well. But there's a problem in terms of like you see this kind of task inquiry or donation equals to 0. They are not natural language sentences, right? While this is natural language sentence, there is sort of a problem. So that's the reason that we separate them out, so that you have like sort of better language model for individual decoder. So another question that you have is how we handle different types of annotation. So what we have is, so you have like 4 decoders. So during the loss function, you basically are adding all of them together as a loss function, right? So do you think, so if you don't have this kind of, the annotations for task inquiry, donation, or provide facts, so what you do is you just update the loss with the NLG. So that's the only thing that you update.
So I guess what I'm asking is, if you look at the purple, that was very helpful, by the way. If you look at the sequence of round states at the bottom, that sequence of circles, there's a jump from the last blue state to the first purple state, and then the last purple state to the first green state.
Yes.
So what would you do if you didn't have the information, the supervision donation equals 0 on this particular example? Would you predict the first green state from the last blue state?
We just use the previous state, yeah. So these ones are just gonna be used the previous ones that I had before, and then we update these kind of red one. And then another one, maybe they have the green and purple, then they update the green, purple again.
Okay, but at test time, you have to predict the green and the purple. And so you always have the intermediate green and purple at test time. Sorry, you have blue, green, and purple at test time. But at training time, you sometimes have it and sometimes just take it to be length 0.
Yes.
So I guess I might worry a little bit about a training test mismatch.
Yes, that's definitely a problem. we there's definitely a biases in there as well. Yes, but what we find is it wasn't that serious when we use our data. Maybe it's because our training. So the ones that sort of the tags that we have is like relatively small. So it didn't really see much of the problem, but definitely there is, if you have like really unbalanced sort of data points in terms of different annotation, I can see that could happen. But potentially you can maybe also still use some like parameters to constrain that. Your loss function, for us, we just use like a sort of everybody is equally important. You can maybe tune them in terms of that you maybe just have this NLU, most of the data you have NLU annotation, but you don't have these two. Probably you can sort of tune it a little bit.
Yeah, I think you can just basically rebalance the training to be more like tests. I didn't mean this was a serious problem. Thanks so much.
Yeah, thanks. So Joe, there is both the Luis and Roshan have questions about personality types. So Luis, you're on. Why don't you ask your question orally? And
okay, thank you. So yes, I'm really impressive for the results of your new your chatbot and this talk is very interesting for us. I'm just curious about the model, the corpora, and the types of personality you are intending to use for the new system, because definitely introducing personality into a chatbot is a very interesting topic, but quite hard to do.
Yeah, I think that's also very interesting. So I had a couple of slides about other work. So one of the ultimate thing that we always want to do is personalize, right? Personalized persuasive system. You can really think about the previous ones. The advertisement is everybody's going to see the same advertisement. Now we go into the Facebook time. You have personalized ads. But it's still an ads, just like a one-time thing. What if you have a persuasive strategy? You can have like multiple things, right? And then it's personalized towards your personality, whatever your history you have. It sounds a little bit evil, but it's also kind of interesting. But what we definitely see in the, so we did some like studies on the, we do find some of the interesting things that we see, like people who endorse freedom and care. If you use social inquiries, like asking about your children, asking about your personal stuff, they donate more. But if the people who endorse fairness and authority, if we ask these questions, they decrease their donation probability. So this is the one thing that we see. So that's why we run studies in terms of tailoring that. And we do find there is effect. But there is a catch in our Kai paper. It's also about perception of whether the chatbot is a human or not. So the study that we do find is the perceived identity has sort of an interaction effect in terms of what strategies they use. If people think that they are talking to a real human and you started to use this kind of personalized strategy, they increase their donation probability. If they think that you're a chatbot, but you pretend to be human and trying to say things about children that a chatbot cannot have, they decrease their probability of donation.
So Roshan, does that answer your question as well? I've enabled your mic if you want to say more.
Yeah, I think that mostly answers it. Thank you.
Okay, great, thanks. There's a question from Zhou, and then one from Sandeep.
Yeah, that's a good question. We talked to Save the Children about it. We have some permissions to like sort of like do experiments, but they're really they're still concerned a bit about the sort of the chatbot's quality, because we recently so there are still a lot of things to improve in our chatbot. So recently we had a cases that we say, oh, blah, 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 Indonesia is having a flood, that their children are really suffering, but Indonesia is not really having a flood. So we decode certain events that are not true because we don't condition on certain events. You know, the generation model is only gonna pick up something because like maybe Florida had a hurricane before people mentioned that. So there is still like some fact checking that we have to do before we actually can safely deploy it for fundraising.
And Sandeep's question, I don't think is visible to the audience. So let me just read it. So Sandeep says, in neuroscience, we talk about theory of mind to understand the beliefs of self and others. how can we train bots to learn in an unsupervised fashion the most effective strategies for persuasion, even new strategies?
Yeah, that's a really good question. So I do believe this kind of theory of mind. So one of our recent work we just submitted to UMLP is we're trying to extract information along the conversation. You're basically building like a personalized knowledge graph for the user and for the chatbot itself. And you keep updating the knowledge graph. And whenever you generate something, you condition on the knowledge to see, you can decode multiple sentences. If one of the candidates does not fit the knowledge graph you have, you filter them. So you only pick the one that is okay. So it can resolve certain consistency problem and also repetition problem.
Great. Alex, Zhou, any last questions from you guys before we close? No?
Great.
Thank you for the brilliant talk.
Sorry, I need
Okay,
Joe. Go ahead.
No, I'm just saying thank you for the brilliant talk.
Oh, thank you.
Yes, Alex.
Yeah, so by the way, that was a great talk. The question, it's a history question. So the sense I got from your presentation is you don't really need much history to generate these dialogues, which doesn't seem quite right. Or maybe I just missed how history was being added. Can you comment on history?
History is important. So we actually combine the history in the dialogue states. So right now in the slides, I only see like donation equals to 0, but we actually have other states that we track. For example, have you donated before? There's like, have you heard about the Save Children before? So we did track sort of the information that is critical through the history. And also for the strategies, we also track them in the history as well. So you sort of want some diversity over time and stuff. You want to use a trajectory of successful conversational in terms of the sequence of the persuasion. So the history was specifically added back into the model through other things. But if we have a neural network model that can actually sort of remember a lot of history, that's perfect. So my student and I, we were looking at, we were doing some work on, we call it memformer. So basically transformer was memory. So we have a block that was in memory. You can read memory and write memory. So that will be more elegant in a way.
Thank you.
Okay, Joe, thank you very much again. Really, that was an excellent talk. Loved it. Thank you.
Thanks, everyone. It's great to interact with the community again. So I'm still some part-time with Alex's group on dialogue evaluation, which is a very exciting topic.
Yes, it is. Yeah. And for those who are joining us from outside the workshop, we have 2 more of these talks scheduled, and we'll have at least 1 more. So the Fridays at 10 o'clock, and we're trying to get a few more people, so it might be some other time than Friday at 10. So keep an eye on the JSALT webpage. We'll post the talks and we'll advertise them again as usual. Please join us. And these are open to the public, so advertise it to all your friends if you like. And for people in the workshop, we also continue with our weekly progress report. So I'll see you all on Monday. We will catch up with what we're doing. Great.
Hi, everyone.
Yes, Joe?
Yes, thank you, everyone. And you have my permission to post the video. Thanks.
Okay, great. Thank you. Thank you very much. Yes. Okay. So that no, this is she's reacting to an internal question, guys, where I asked if we could release this recorded video on the web, and now we have her permission. Thank you. Okay. Luke also said thank you in the chat. Yes, thank you, everyone. Let's close this day. Wherever you are in the world, have a good weekend, and we'll see you, some of you, on Monday.
Bye.